CCNA by exam topics. Domain 1 Network Fundamentals. Subdomain 1.1 Explain the role and function of network components. Let's not make this more complicated than it needs to be. Cisco wants you to be able to explain roles and functions of these network components. Layer 2 and Layer 3 switches, next generation firewalls and IPS, access points, controllers, endpoints, servers, and power over Ethernet. This is pretty straightforward. Buckle up. When you take a look at this network topology, you can put the devices into two major categories: network components and endpoints. Network components are all devices that are used for transport of data from and to endpoints. So an endpoint is a device that is not used for data transit. These can be servers, PCs, monitors, printers, surveillance cams, POS systems, HVAC systems connected to IP network, etc. Servers. They are endpoints with high computing power and hardware that supports 24/7 operations. These devices are used to provide some kind of service to remote users. Most common are web server, file sharing server, database server, application server, mail server, print server, DNS and DHCP server, streaming server, etc. Switches you find in today's networks can generally be categorized as either Layer 2 or Layer 3 switches. Layer 2 switches are traditional switches used to forward traffic based on the destination MAC address. Layer 3 switches are more capable switches. They have an IP address for VLANs they support and can forward traffic based on destination IP address. They can even form routing protocol neighborships with routers or other Layer 3 switches. Routing, which happens at Layer 3, inherently prevents Layer 2 loops and broadcast storms from crossing network boundaries, or VLANs. This is why Layer 3 switches are more common in modern networks than their Layer 2 counterparts. Layer 2 switches run spanning tree protocol on all links connecting to other switches to prevent loops and broadcast storms. PoE, or Power over Ethernet, is a technology that enables us to power certain devices like telephones, CCTV cams, wireless access points, or POS devices using power from an Ethernet cable. In order to do this, the switch you want to use for powering these devices needs to support PoE on the specific ports. And also, the powered device needs to support this feature. PoE gives us an advantage of not having to run power cables or have power adapters for remote devices, saving us costs and lowering complexity of our infrastructure. Access points, or wireless access points, are used to transmit and receive data over the air for wireless devices. They act just like a network cable but use air as medium of transport. They can be standalone, meaning that they have configuration of VLANs and SSIDs, aka Wi-Fi names, they will be broadcasting. Or they can be lightweight, meaning that they are only used for data transport, but all configuration is pulled from a remote wireless LAN controller. Controller is any device that is used to control a number of different devices. The controller is providing all the necessary configuration to the controlled devices, firmware, software updates, security patches, etc. The controlled devices have minimal capabilities and minimal hardware complexity. The best example of controllers in networks are Cisco wireless LAN controllers, or WLCs. These devices are used to control and provision a big number of wireless access points spread across multiple buildings and multiple VLANs. Advantages of controller-based networks are that you can install new wireless access points or replace broken ones with minimal involvement of network technicians. The newly installed access point will initiate connection to the controller and will receive the software image, an IP address, and configuration of what SSIDs it needs to broadcast to that specific location. Firewalls traditionally act as a network's first line of defense, filtering traffic based on basic rules like IP addresses and ports. However, modern threats require deeper inspection. This led to next-generation firewalls, or NGFWs, which expand on traditional capabilities by adding deeper packet inspection, application awareness, and often integrating other security features like intrusion prevention. An intrusion prevention system, or IPS, takes security a step further by actively monitoring network traffic for malicious patterns and signatures and automatically blocking or preventing detected attacks in real time. While traditional firewalls did filtering, next-generation firewalls and integrated IPSs provide more intelligence detection and active prevention against sophisticated threats. Thanks for watching. See you in the next one.